thinker, and welcome to Waveforms. This is an episode where we're looking at the rather interesting aspects of how waveforms are measured and what they relate to, and therefore extrapolating how they relate to our lives. So, okay, let's just have a little look at this equation here. It's known as the Planck-Einstein relation, or just the Planck relation, depending on where you look. And it's denoted an equation that describes the energy of a photon. Photons, particles of light. Energy comes in many variable formats, lots of different kinds of packages of energy. There's kinetic, potential, there's the velocity, and the mechanical work energy that are denoted by these various letters here. If you're taking energy as a quantity, then you've got to bear in mind that it takes lots of different forms. And in our experience of life, of course, energy takes lots of different forms in the way that we use it, in the way that it comes to us. This is Planck's constant, denoted by H. It's a letter that you're going to see very, very often in lots of physics equations, and what it actually means is a numerical value. It was a numerical value that Planck derived from black body radiation, which is something you're going to have to go and look up, essentially. It's about thermal distribution in a black body context. So this constant, oh, hello Wordley, are you going to join in? Yes, Wordley wants to join in with the proceedings. This constant is a numerical value. It's a mathematical evaluation. Do you want to come here, Wordley, so that I can explain what's going on? There you go. Wordley's looking in very good condition. As you can see, he's improved considerably from the poor little thing that you've seen right at the start of these videos. And I'm very glad to be able to say that he's happily come down to join us today and wants to be in on the act. Anyway, as I was saying, Planck's constant relates to lots of different avenues of physics, but generally speaking, you can just think of it as a mathematical value that applies to various aspects of quantum mechanics. F is frequency, and that's where we get into the waveform kind of territory. Frequency of a wave, the speed, the number of times it oscillates per second. The frequency of a wave is the number of peaks and troughs that you're cramming into a particular unit of time. Wavelength, which is represented here by little v, is the distance between the peaks and troughs of the wave. So this is the length of the form of the wave here, for instance, from crest to crest, how long it is. Radio waves are really, really long. And gamma waves are really, really short. So right across the electromagnetic spectrum, you've got varying frequencies and wavelengths of waves. Frequency and wavelength are inversely proportional to each other. So they directly relate to one another. If you've got short wavelength, then generally you've got high frequency. Specifically, even you've got high frequency. Short wavelength equals high frequency. It's just a thing. And this little symbol here, this upside down Y, also known as a lambda, is wavelength and charge density and eigenvalue. Eigenvalue tends to be the natural value of something. So if we're looking at the speed of light or the behavior of a photon, then you can see how natural laws may well apply to this in mathematical states. Quite why you see it sometimes reversed, as in this context, I have no idea, but from time to time I have noticed this, and I don't know why. Maybe you can tell me. Scientists amongst you can elucidate in the comments, please. Now, another interesting aspect of waveforms that I want to explore is this one. This represents a standing wave format. Now, a standing wave occurs when you've got two waves coming in from opposite directions, counterbalancing each other, effectively. So if you've got two waves coming in from opposite directions, they are going to cross over like this. And they produce a standing wave. Now this again is something that's well worth looking up, because there are lots of physics papers and wiki contributions and so on and so forth to give you a really good idea of what a standing wave actually is. But this is a simplification in the drawing of it. So when these two waveforms come together, where the peaks come together, the energy is combined to produce, in the standing wave, a bigger peak. And where there's the dip in the waveform, you get this leveling out effect. So standing wave kind of goes like this, with a big peak and then a flat line. There's a big peak and then a flat line. And this is the combination of two waveforms coming in and crossing each other. It's kind of complementarity, a weird form of wave. And the reason why I think standing waves are so interesting is in relation to the way that we move through time. Now, going back to the old Planck's constant here, you're going to see Planck's constant applied in all sorts of various aspects of physics, not just in black body radiation, but in other sort of thermodynamic distribution systems. The uncertainty principle even has the Planck's constant put in there somewhere. So there are lots of variables as to where this constant is applied, because it's a mathematical value. However, when it comes to real life, we don't have mathematical values to work with. We've got an existence, a plane of existence to work with, and that's why this stuff is so important and it's so interesting. This is a diagram of time. It represents the way we work with time. Now, as I've explained in previous videos, time works on a toroidal format. It's like a big ring donut of past, future waves coming in together at the same time and colliding in the present moment. So that essentially is what time looks like. We kind of live on a disk of time, and our perception is that it moves only in one direction. Time's a kind of a one-way street to us. We go from past to future in our world line that we travel through life. But that doesn't mean to say that there is not a future to past waveform that is equally at work in the creation of our present moments. So as we go through time, we're existing in present moments that are created by waves coming from the future to the past and waves coming from the past to the future, which are the ones that we perceive. So in reality, we could be said to be existing on a kind of a standing wave platform. How that extrapolates to our dealing with everyday existence? Well, it means that our energy levels correspondingly can be higher than the energy of the time that we're existing within. And it can be lower than the time energy that we're existing in. Because if we're constantly on a standing wave of past and future, advanced and retarded waves, scientifically speaking, coming in to create the present, then we are subject to these peaks and flat lines of energy, as in this diagram here. So it's useful to know where we are it's interesting to know that we've got all these different varieties of energy at our disposal, and they all relate to us, which is, of course, the whole point of the quantumology exercise. Everything that I produce in my videos and that I present to you on these charts is for further exploration. It's to whet your appetite, to go out there and look into the physics, look into the papers and the articles and the ideas that are presented by scientists and non-scientists all over the place. Because quantum mechanics is a very, very deep field, and it means a lot to us. It means a great deal to the way we live, our management of self, and the things that we can do with our time, our world lines, and the energies that are available to us. So please explore more. Comments very welcome. Love to see them on the thread. And we'll see you again soon. Don't forget to look us up wherever you want to find quantumology on your search engine. We're pretty much everywhere. And do subscribe to the channel so that you can get this content as soon as I create it. Thank you very much for joining me, and look forward to seeing you soon. Love you loads. Bye.